In this video, we're going to look at how to graph a polynomial, or at least to get some kind of sketch of a polynomial. We're going to use any zeros. By zeros, I mean where it crosses the x-axis. We're going to look at the end behavior, like what happens way out at the right and way out at the left. The y-intercept, where it crosses the y-axis. And we can also look at the signs, that whether it's positive or negative, the polynomial, either side of each of the zeros. So wherever it crosses the x-axis, whether it's going to be positive or negative. And that helps us to graph a polynomial also. Now we're going to start by doing it the hard way. And by that, it's this first example, example 5, we have to do a lot of work. We'll see when we do example 6 that we can simplify the work a little bit using the idea of multiplicity of a root. But example 5, we'll do it the hard way, and you might want to, if you have a problem, just do it the hard way just to check that what you think is the case with multiplicity actually works. So example 5, we've got to graph the polynomial equals x cubed minus 2x squared minus 8x. Now we can find the zeros, that is where it crosses the x-axis. We can do that by factorizing this thing here. So if we factorize that, we can take x out as a factor, and then we can factorize the x squared minus 2x, and if we do that, we'll get x minus 4 times x plus 2. That gives us 3 roots. It gives us a root at negative 2, it gives us a root at 0, and it also gives us a root at 4. Right? Those numbers, if you don't see them, come from this x equals 0, x equals 4, and x equals negative 2. That's what gives us these. If you do that, what we want to figure out is what happens either side of the negative 2. We know that when x is equal to negative 2, our polynomial, our y-coordinate, is going to be 0. We can actually see that on the graph here. We've got negative 2, 0. Now the question is, are we going to be down here or are we going to be up here to the left of negative 2? So we want to know whether to start here or whether to start down here. So we try a value of x that is less than negative 2. A value of x that might be negative 3, for example. So we take something that's to the left of negative 2. We also want to know where the function is between negative 2 and 0, so we're going to try a value of x that's between those. This 2 is between 0 and 4, and 5 is to the right of 4. When we do that, when we plug in x equals negative 3 into the polynomial, what we get is, if you put in negative 3 into this thing here, we're going to have a negative, like negative 3 times negative 7 times negative 1. So that's a negative times a negative times a negative, negative times negative, negative. When you multiply those all together, you'll get a negative. And that tells us that the function is going to be, we're going to have a negative coordinate for our y. We're going to be below the x-axis, somewhere down here. That negative tells us we're way down here. If we do the same thing, but with minus 1 instead, then what happens when we plug minus 1 into this is that we get a negative times a plus, and that gives us a plus. So that tells us that we're going to be above the x-axis between negative 2 and 0. Again, when x is equal to 0, our y is going to be equal to 0 here. When we have x equal to 2, what happens there? Well, we put our 2 into the polynomial, we get a positive times a negative times a positive, that gives us a negative. So that means that we're going to be below the x-axis, down here, between 0 and 4. Between 0 and 4, we're below the x-axis because the y-coordinate is going to be negative. Again, at 4, when x is equal to 4, we're going to be at 0. And then we've tried 5 in this polynomial here. We're going to have 5 times 5 minus 4 times 5 plus 2. That's a positive times a positive times a positive. So when we try that, we'll get a positive times a positive times a positive, which is then going to be positive. So, and that means that we're above the x-axis to the right of 4. Anywhere to the right of 4, we're above the x-axis. If you should need to know what the y-intercept is, anywhere on the y-axis, x is equal to 0, so we just substitute x equals 0 into this expression or into this expression here. If you put x equal to 0 into this, we'll get 0. And so we have the point 0, 0. We already had it in this example from here. Right, and joining up the dots, we should get the graph as it is here. Now that's the hard way, but you might want to do it like that to check that you've got things correct. An easier way is to use the idea of multiplicity. And the multiplicity is given by the powers that go with the roots. So in this example here, this x minus 3 gives us a root, a 0 of 3. It goes through the x-axis at 3. And the 2 tells us that is the multiplicity. The 2 is the multiplicity of this root of x equals 3. 5 is a multiplicity of the root x equals negative 2. 5 goes with the root negative 2. And can you guess what goes with the x equals negative 4? There's a kind of invisible 1 up here. So the multiplicity of x equals negative 4 is 1. Now, why is that important? Because if this number up here is an odd number, that tells us that we go through the x-axis, right? We go through the x-axis at at negative 2, because this 5 here is an odd number. However, if it's an even number, like this one here, that would tell us that we don't go through the x-axis at x equals 3. What happens instead is perhaps something that looks like this. We go down, and then at x equals 3, we don't go through the x-axis, we just kiss the x-axis, we touch the x-axis, and go back up again. So again, if it's an even number here, we just touch the x-axis and go back again. We don't cross over. Now let's see how quickly that can allow us to graph something that's given in this kind of form. We have 3 places that it's going to cross or touch the x-axis. It's at negative 1, at positive 2, and negative 3. Right, so those are our zeros, possible places for crossing or touching the x-axis. We can put those in this table. It's at negative 3, at negative 1, and also at 2. Now the multiplicity of negative 3, is 2. It's even. The multiplicity of positive 2 is odd. So we're going to just fill in the multiplicities down here. Multiplicity of negative 3 is 2. The multiplicity of negative 1 is just 1. There's an invisible 1 up here, if you like, because x plus 1 is the same as x plus 1 to the power of 1. And this last one here is just going to be 3. Now, what does that tell us? Well, it tells us that when we have x equal to -1, we're going to go through, when x is equal to -1, we're going to go through the x-axis because we have an odd multiplicity. This -1 means we're going to go through the x-axis, and we're just going to touch the x-axis at -3. At -3, we're going to touch the x-axis. We're not going to go through, we're just going to touch it. And because at 2, we have an odd multiplicity. At 2, we have an odd multiplicity. Again, we're going to cross at 2. Now, how do we know if we start up here and touch this, or whether it should look like this? That's from the end behavior of this function here. If we took some time and multiplied everything out, we would have an x squared term from this, multiplying all this out. We would have an x cubed term from this. We'd have an x term from this. They're all positive, all multiplied together. We'd end up with a polynomial that would be x to the power of 6, blah, 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 blah. If we're graphing something that starts with x to the power of 6, where the leading coefficient is 1, is a positive number, we have something that effectively starts at the top left and ends at the top right. It's kind of like that. So the end behavior starts top left, ends top right. So that tells us that we've got to start at the top. We go down, we know that we've got to just touch the x-axis at -3 because the multiplicity of -3 is even. We go back up, at some stage we've got to go down. At -1, we have to cross over. We have to come back up at some stage, and what happens at 2? Because it's an odd multiplicity, we have to cross over, and that's us. So we have an idea of what our graph is going to look like. Okay, we don't know what this point is, we don't know what this point is, but we at least have some idea of what's happening with the graphs.